good evening, good afternoon. I don't know what suits best for you, dear audience. My name is Pierre Gilles, and I would like to speak a little bit with you on the topics, which is the main topic for every bridge engineer when we have to rehabilitate bridge. What is the best to rehabilitate bridge, and which solution, which method to use, or reconstruct the bridge. But first of all, I would like to present myself. I say that I came from Belgium, and more precisely from Wallonia. Belgium, as you can see here, is a little country in the center of Europe, and this country is divided into two districts, and Wallonia is the south district. It's not very great, as you can see here, about 3.5 million inhabitants. I'm working in a road administration. We are managing highways, roads, waterways, greenways, and of course bridges, with about 5,000 bridges. So, as I say at the beginning, as a bridge engineer, bridge manager, we have often the same question. Well, how can we select the best rehabilitation method? And that's why the Road Bridge Technical Committee of PRAC was involved in this issue, and we finalized a complete report about that, and I will present you a small part of this report. But first of all, let's consider an example: a common bridge, a multi-span concrete girder bridge, with this 40 years old. You can see it here on the picture, and the girder is made of post-tension concrete beam. And while we are in Belgium, so in the winter we have snow, we have to put some de-icing salt on the road. While due to some default in the waterproofing, this chloride product go inside the post-tensioning dirt, and the grouting was polluted by chloride. So we performed some investigation. We opened some cable. You can see here one cable with the different wires. You can see that the injection is quite very good. There is a very light corrosion on the wires, but it's really not a problem. But the really problem is that the chloride content is about 10 miles the acceptable limit. So what can we do with this? There is in fact no degradation, but we know that with chloride and with a few moisture content, we can have with time important corrosion, and we know that corrosion on post-tensioning cables is very problematic, and we know also that even if we renew the waterproofing and there is no more any ingress of water inside the cables, the water that still is contained in the grouting will interact with the chloride and produce some important corrosion. So what will we do in the future? That's our question. We can imagine different kind of scenario. First scenario, we say, well, we renew all the superstructure, girder and slab now. The second scenario, and it's a little bit the same as the last one, we decide, well, we make some investment 40 years ago, and we still consider that this investment is still usable. So we will keep the superstructure, and we will rebuild it only in 20 years or in 10 years in the last scenario, and we will only make a moderate or a light slab rehabilitation today. And the third scenario is to reinforce the girder with fiber, for example, in order to compensate the future degradation of the post-tensioning. And with this solution, we can expect to maintain the initial time life of 100 years. This is an example with 4 kinds of rehabilitation, 4 kinds of strategy of rehabilitation, either reconstruction. This kind of question has already been analyzed in the past, and we find that there was a BRIME project for bridge management in Europe that has been performed in 2001. And this report highlighted, in fact, by most countries, there is no specific tool available to determine which kind of rehabilitation solution we have to implement, or if it is better to rehabilitate or to replace a bridge, except Denmark, USA, and Finland that has some methodology. And the BRIME project proposes own strategy to determine this comparison between the different options, and they propose to calculate a global cost C, which can include any cost that you want, the works, of course, but also user cost, so the cost related to the fact that people will lose some time during the congestion due to the works, for example, or also some environmental costs that you can include, so you can do what you want. And the idea is, of course, will be to reduce the cost, but keeping, of course, a stable structure. And you will be able to compare 2 solutions, and for that they introduce the repair index, which is the ratio between an alternative, the cost of an alternative solution, and the cost of a reference solution. So we perform the work in Pierre some later, nearly 20 years later. So we wanted to see if there was any change comparing to this BRIME project. So we sent many a questionnaire, and we got answer from 17 countries, about a little bit from everywhere in the world. And well, the conclusion is that there are still no specific tool to compare rehabilitation methods in the most countries. We will see that there is some exception. And how did the people mainly perform this comparison between the different kind of rehabilitation method? While they can perform a technical meeting, it's quite easy. They can also compare the different cost of the different solution, but at present time. And finally, they can also make a life cycle analysis performed on the analysis period that is performed by the Canada, Ontario. What was the life cycle analysis? Well, in fact, you will consider a certain period, an analysis period. This period can be 60 years, 40 years, 100 years, for example. It's not related directly to the time life of the bridge. It's another period. And during all this analysis period, you will determine all the different kind of costs, the cost of the works, of course, the user cost, environmental cost, every cost that you find important to take into account in your comparison, and this can be different from one country to another. So we decide based on the answer that we receive, based on the BRIME report, and based also on different internal discussion that we had inside the PR committee. Well, we decided, in fact, to introduce this decision process inside the global bridge stock rehabilitation process in order to produce 2 main elements: to produce an annual rehabilitation program, which is also something interesting, and to determine for each bridge the most suitable rehabilitation solution. I will focus only on this part of the object, but you can find all part of the goal inside the final report. So we have to compare different kind of rehabilitation methods, and to do that we will consider different scenario, and we will look on every step that has been to be performed during the analysis period. If I look to this first scenario, for example, I can see that I will perform a light slab rehabilitation now, and that in 20 years I will renew all the girder and the slab, including waterproofing and pavement. So this is related, of course, on the example I show you at the beginning. And then 10 years later, I will renew the pavement. 10 years later, I will renew the waterproofing and the pavement, and then only the pavement 10 years later, and then again 10 years later, the waterproofing and the pavement. So I have a cycle of replacement of the pavement every 10 years and of the waterproofing every 20 years. This is all the operation that I will have to done on this bridge during all the analysis period. I will consider during all this period all the cost of the different kind of works due to rehabilitation or maintenance operation. And in this example, I will only consider the user cost, which is the cost that is related to the congestion due to the works. When you perform this calculation, it's very important to notice that the user cost will be very higher than the work cost, in fact, and the ratio can be 3 or 4 mile. It can be important, and sometimes it can be difficult because the user cost is the cost that you, as a road administration, for example, you will not have to expense as money, because that is all the people that use the bridge that will have to expense this cost. But if we consider the global society, it's important to take this into account. And all these costs, we will express all these costs at present time, because you have seen that I have different kind of operation in 20 years and 30 years and so on. So in order to compare all these costs at the same time, I express all these costs at present time. How can I express a cost that will occur, an expense that will occur in, for example, 20 years? How can I express this cost today? I can do that using the discount rate. You have here this relation between the cost in the future and the cost of the same operation at present time. And you can see that it is a function of the discount rate R and the number of years. So I have all the costs today, but it's also difficult sometimes to know what will be the cost of 1 cubic meter of concrete, for example, in 20 years. I know the cost of 1 cubic meter of concrete today, but what will it be in 20 years? I can also calculate this based on, of course, the inflation. And I have a relative similar equation, which give you the cost in the future based on the cost today, using the inflation and the number of euro. And you can see that if the inflation and the discount rate are the same, well, the two operations are the same effect, but inflation and discount rate are different. We can see that a little bit later. So now we have all the costs at the present time. We need to compare the different rehabilitation methods. We can use two methods. The first method is the net present value, is based on the net present value. And so for each rehabilitation method, we will consider all the costs due to the works and the user. And we will also take into account the residual value of bridge at the end of the period, because depending on the scenario, at the end of the analysis, perhaps I will have a bridge of 10 years old or a bridge of 50 years old. So I need to take into account this residual value. And so I can, taking these two aspects, I can determine the net present value. And well, the idea is to select the method with the lower net present value. The second method to compare is to to minimize the benefit cost ratio. It's an easy concept, but it's quite difficult, because when we rehabilitate a bridge or you rebuild a bridge, what's the benefit for the user? Previously to the operation, he has a bridge. If the rehabilitation don't increase the load capacity of the bridge, if the rehabilitation don't increase the number of lanes, after the rehabilitation, the benefit is simply zero for the user. Previously, he has a bridge, and after the operation, he still has a bridge with the same service level. So it's quite difficult to express a benefit. So we will, in fact, express a benefit of one solution comparing to another solution. And the base solution, the base scenario that we will take into account is the scenario with the less expensive cost. So I can express, by this relation, I can express the benefit of one scenario comparing to the base scenario, the scenario O. And you can see that this expression has two blocks. The first block is, in fact, the difference in traffic impact between the two scenarios. And the second block is, in fact, the difference of the residual value of the bridge at the end of the analysis period for each scenario. So if I make the sum of these two differences, I can express a benefit of one solution of one scenario comparing to a base option scenario. I have the benefit, the cost, that's very easy. So I can divide this benefit of one scenario compared to the base scenario, divide by the difference in cost between these two scenarios. If the value is lower than 1, well, then the scenario G is not suitable. We will expend more money. We have more traffic impact for comparing to the scenario O. So we reject the scenario G. If this ratio is higher than 2, then, well, the scenario G is highly suitable, and we propose to keep it and to draw away the scenario O. And if the ratio is between 1 or 2, well, there is a little advantage in the scenario G, but we have to take into account the different kind of uncertainties that exist in this process. Which are these uncertainties? The first uncertainty is the evolution of the inflation rate. During the calculation on an analysis period of 40 or 60 euros, I will take one value of the inflation rate. Which kind of value will I use? You can see here the evolution of inflation in Europe during the last 30 years. You can see that, well, it's quite important, the variation of this value. Actually, we consider 1%, but what is the best solution, best value to take into account on a long period? That's the first uncertainties. The second uncertainties is the discount rate. And I will take a little time on this graph because the discount rate sometimes is not easy to understand what it is and what is the difference between the inflation. If I consider 100 pesos, I don't know if it is the money in Costa Rica, excuse me, let's consider pesos. If I consider 100 pesos that I will expend in 60 euros, what represented today? If the discount rate is 1%, I will take this curve, and 100 pesos in 60 euros represent 55 pesos today. If the discount rate is 5%, it is the blue, the light blue curve here, the same 100 pesos that I will expend in 60 euros represent 5 pesos today. So the higher the discount rate is, the higher I am encouraged to have an expense in the future. So I will also give to the future, for the future generation, a great impact on the investment that they will have to do. So it is there is an economical point of view, but there is also a symbolic point of view. Which kind of weight will I give to the next generation? So you can see that, for example, in France, until 2005, they use 8%, and actually it was reduced to 4%. In UK, they use something interesting because they use a value of 3.5% as discount rate, but they propose also to decrease from 3% at 30 euros to 1% at 300 euros, the discount rate in long term. So in fact, you are going up in this curve. And finally, in the US, they propose to consider two values of the discount rate in your calculation, 3% and 7%. Finally, you remember that I make some scenario with different kind of operation of works and rehabilitation and the maintenance of operation. Well, I am sure that in 30 years I will renew the pavement. I am sure of that. I'm not sure of that. I'm not sure that the maintenance program that I imagine during all these analysis process will be really done. And the best example is to look to the bridge, to all bridges that we have in our stock, and generally, in fact, in Europe, I'm sure, other countries, in Costa Rica, I don't know, I don't have a good overview of your bridge stock, but in Europe and US also, the bridge stocks suffer from a default of maintenance. So this kind of program was not a respect in the past. So I have to take that into account also in this operation. Well, how can I manage all these uncertainties? But the best way is to repeat the comparison process using different kind of data sets. For example, I can consider different value of the analysis period, 40 euros, 60 euros, 30 euros. I can also change the discount rate to see what's the impact. Perhaps I can also have different kind of maintenance program and so on. I can imagine different kind of data set depending on my country and my expectation also. So if I go back to my example of the beginning, you remember I have 4 scenarios. first scenario I rebuild now, and then different kind of rehabilitation program. This is the data set that I used to perform the calculation, and I decide to have a kind of parametric analysis on the analyzed duration, on the discount rate, and on the number of days with traffic delay. And if I do that, what are the results? With the initial data set, I can see that the scenario 3 seems to be the best solution, even for both comparison methods, the net present value and the benefit cost ratio. If I reduce the number of days with traffic delay, so I reduce the user cost, in fact, well, the scenario 3 remained the best, but I can see that with the net present value, the rest scenario 2 becomes a little bit at the same level of the scenario 3. If I increase the analysis periods from 40 to 60 euros, there is no change. If I reduce the discount rate from 5 to 2%, well, I can see here with the benefit cost ratio difference, solution 1 became better. That is important. It is evident because when reduced the discount rate, the expense in the future will have a higher impact to today. So it's better to rebuild the bridge now than in the future. And if I increase the discount rate from 5 to 8%, while scenario 3 remain the best. So with this very short, I agree with you, it is very short, very simple parametric analysis that has been performed, but I have a certain confidence for the scenario 3. So as a conclusion, this process that I show you, we propose to use it for project with a certain big importance. For medium importance projects, it's better to compare only the cost at present time using the works cost, the user cost. And for very low project, well, just use your engineering judgment as you use it every day. You will find all this and more the complete process in the final report. It is available on free on PIAC website in Spanish, in English, and also in French. Thank you for your attention, and I will please answer to your question. Thank you.